Alright guys, this is Alg2 2.2.5 and this is day 1. So we're going to be talking about transforming piecewise functions as our main focus for these 2 days. So to start off on 153, what I want you guys to do is go ahead and pause the video, work through that, and then go and do 154 as well. And using this graph here, we're going to try and write an equation that models it. All right, so go ahead and pause the video and try that out. Okay, so what we should be getting here is in our piecewise function. We want all of these. We're seeing this being at $40, right? And then this is 45 cents higher from on this region here. So it'll be 40, 45, and this is 40.9. Oops, spoilers, and 40 and 41.35 and so forth, right, as we go for all of those different steps. Now the key thing here is we want those domain restrictions on those as well. So we're going to have the first one from 0 to 450 as the domain. Make sure that the or equals to is on both ends there, because it does go from $0 and up to 450 and including 450 minutes. And then our second set, that's from 450 to it's every minute after that. So from 450 to 451, and the or equals to is on the 51, and then from 451 to 452, and then again the or equal to is on the 52, and then 52 to 53, 53 to 54, 54 to 55, right? So that should be what your piecewise function looks like. Right? So that is a special type of piecewise function. It's called a step function. Now, not all piecewise functions are step functions, but step functions are kind of the easiest way to kind of introduce us to the idea, because there's zero complexity in the actual equation. It's just a horizontal constant value, whereas other ones, it can be any type of graph you have ever seen. So they can be from simple lines to very complex graphs as well. So that's what we kind of start there, and we're going to work our way up to the more complex stuff. So when you create your own, again, the equations can be whatever you want. They can be as fantastical or as basic as you would like. The key thing that I want you to check is on yours, do any of the domains overlap, right? That means if you were to graph it, would any of the lines make it fail that vertical line test, right? Because if they're overlapping, then it's going to fail that vertical line test. So they have to be kind of, typically they will have this one will stop exactly where this one starts. So you have that open dot and that closed dot, as we see over here. So just kind of double check that you have that to make sure that yes, this is in fact a function. Okay, so here's the big crux of what we're going to be doing here. So I have a graph here. This is a piecewise function. We can definitely see a few distinct parts here. We have a part here, we have a part here, then we have a, looks like a parabola part here, then we have a part here. So what I want you to do is first fill out this table for it. So this is a much larger, more complex table, but I will tell you that all of these numbers are going to be nice, pretty whole numbers, so it's not going to be too bad for us. And then once you have that, use that to create an equation that will model a piecewise function, sorry, that will model this actual graph. But start off with that table first. Okay, so pause and do that. All right, so back here, let's go ahead and try that out. So I'm going to hop over to this view. And for my piecewise function, I'll say f(x) is equal to, I'll start my big curvy bracket. So the first region that I see there, I'm going from -4 to -2 on my domain, and my value there is consistently -2, right? So it's just -2 for my y's, and I do that from -4 until -2. So that's going to be my domain there. Now I have some options here. Since these join, if you can see my cursor on that little screen, um, since these join at these intersections, right? I can either put my or equal to here and then not put it here, or put it here and not there. It doesn't really matter as long as if they intersect. We just don't want to put it on both. So I'm going to not put it here just so that I don't accidentally also put it here. So, all right, my second set, I clearly have this kind of downward sloping line here. So that is going down one and right one. So that's a pretty easy slope. They're not trying to make this challenging for us. So that's a -1 slope. And I have a y-intercept at -4. So that would be -x minus 4. Now I want to be following that graph under what region? Well, I'm going to pick it up at -2. I'm going to do or equal to because I didn't do it here. And then I'm going to stop that one when I get to an x value right there, which is at +1. And then I'm going to pick up my parabola-looking curve from that 1 up to here at 4. So that parabola is probably going to be the more complex thing. I'm going to come back to that one last. My final one is another horizontal line at a value of 4. And I'll make this back a little bit longer so I can fit it all in there. 4, and I want that one's domain to be from 4 until 7. And I do need the or equal to on both parts here because the 7 is a solid dot, so I got to make sure that I have that. So equation-wise for that parabola. Now, you can't always do this, but the ones which we're going to be doing right now, they're not going to try and trick you. The vertex for this parabola is right there at the intersection. Okay, so this is a parabola that has been shifted to the right one and then down 5. And I know that it has not been vertically stretched at all because the next whole point that I get is over 1 and up 1, and then over 2 and up 4. So it's going to be a standard parabola shape that's just been shifted. So I can do that by doing x minus 1 squared, which gives me that shift to the right 1, and then I went down 5. So I want -5 on the end, which gives me that vertical shift down. And then I want my domain there to be from 1, and I want or equal to because I didn't use it here. And I'm going to stop that one at 4 because that's where it ends there. So that would be the equation, sorry, the piecewise equation or piecewise function for that particular graph. And then table-wise, slight spoiler for the next thing which we're going to do, but here's what you should have gotten for that table. So let's hop back over here and we'll come back to that page I just pulled out in a second. Because our next thing is doing this. Okay, so we're trying to do some transformations of piecewise functions, right? Which seems kind of intimidating, but really it's not different than anything else we've done. I told you all of these transformation rules, why they're useful for us is because they work for any function. Even some ugly piecewise function, it'll still work for us. So that's what we're going to try and do here and see with this little sheet. So I normally would give you this worksheet, but since you're not here, I'm going to try and show it to you in this way. So what I want you to do is just kind of generally sketch what this graph would look like, right? And you should all already have the base table made from the last problem. Okay. So what we're going to do is, well, if f of x is this, what's negative f of x, right? All that's going to do is take all of these values and change their sign. So my negatives become positives. So this is now 2, 2, 2, 3, 4, 5, 4, 1. And now these positives are now negative. So -4, -4, -4, -4. Okay. So then if I want to graph that, what does that look like? Well, this is going to be translated here, 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 and then here, and then here, 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 here. So let's put all of those points there, and then what that looks like is if I draw it's horizontal there, it's an angled line there, and I have my parabola portion kind of going down to that spot, and I'm horizontal there, right? And that does what we kind of predicted, right? It gives us that vertical flip over that x-axis. Awesome. Well, let's try this next one. Okay, so this one, we're going to be taking the entire function and just multiplying it by half. So that takes our f of x, or our output, multiplies all those by half. So I'm going to do that for my table and use that table to help me figure out my graph. So this -2, half of that is -1. -1, -1. This would be -1.5. I'm going to do decimal just because it'll be a little bit easier for me to graph those. -2, -2.5, -2, -0.5, and then +2, 2, 2, and 2. So if we go ahead and plot all of those, here, 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 and then -2, -2, oh, sorry, -2, there, not there, -2.5, and then back to -2, and then -0.5, and then 2, 2, 2, and 2. So if I now draw my lines between all of those, it's not angled, great. And then it goes up like that, and then horizontal, like so. Okay, so we're seeing that vertical compression by half. All my y values were now half as tall, so everything it's half toward that x-axis for us. Okay, so since this is a 2-day lesson, the latter half of this, because as you see there, there's 2 more. We're going to do those other 2 on tomorrow's lesson, and then we're going to finish off there. So that is it for today's. Let me pull up the homework for us. So our homework for today's lesson is 162 through 169. And I'll talk to you next time.